All right. Morning, class. Morning, Cassandra, Madeline, Rachel. Thank you for being here. All right. How are you today? Tristan is here. Okay, let me move this. Tired, Rachel. Sorry to hear that. Yes, it's the middle of the semester. Is usually the most difficult part of the semester, but you are doing great here. So keep working hard. Okay, just quick testing. Is audio, video okay? Can everyone hear me well, and is the video feed correct? Okay, thank you, Madeline. Thank you, Rachel. All right, so I'm going to start today with 3 questions. Okay, thank you, Tristan. Morning. So we are going to be working Unit 8. You will see that in Unit 8, we are going to, on the past 3 units, we have been learning about polynomials and rational functions. And like I mentioned before, we have been learning its properties. Okay, eventually you will be using those properties to take advantage of or to use as in applications in real life. Okay, where polynomial might be the tool or the aspect that you will use to solve a problem. Unfortunately, for test number 2, we are going to stay in the abstract part of polynomials. Okay, but Unit 8 is a very good example of what we are going to do in the future when we have all that knowledge and we want to make and we want to apply that knowledge in a optimal way. Okay, so Unit 8 with this, what I'm saying is that Unit 8 can be a very easy unit. That all will depend on what can you take advantage on from the previous 3 units. Okay, you will see that how we are going to use those topics that we have learned from those units. You will see how we are going to take advantage of them in this unit to solve inequalities. Inequalities initially could seem very like a very difficult topic. It is, but we can make it very easy, right? So what we are going to do, like I mentioned in the announcement, we want to know exactly what is the meaning of the zero of a polynomial and what is the restriction of a rational function. So to review that, I'm going to pose a poll here, 3 questions, very easy, and let's see how you answer those. Okay, so I believe you are seeing right now a poll in, if I'm not wrong, let me just make sure that everything here is correct. Are you seeing like 3 questions on your end? Perfect. Thank you, Halima. Good morning, Amanda. Amanda, we are working with these 3 quick questions before we start our class. Okay. All right, so I have here just 1 answer. When you are ready, submit your answer. I have 2 answers, 3 correct. That's good. How many people are here? 1, 2, 3, 4, 5, 6, 7. So we are 7. I have only 4 of you have participated. All right, let's do a quick check-in. Okay, we have 5. I need 2 more answers. All right. 6 answers, 1 more. All right, so I think I have all my answers. Okay, that's what I wanted. Thank you. So there are 3 questions, and the purpose of this is to review how to identify a zero for a polynomial, what is the relationship between a zero polynomial and its linear factors, and what is the restriction of a rational function. Okay, so let's start with the first one. We are seeing the polynomial 7x times x minus 3 times x minus 3. Okay, we have 3 linear factors there. We have x minus 3, and x minus 3. X minus 3 repeats itself, so because I wasn't able to put an exponent in the question, then I put the 2 linear factors there. But we can see that counting the linear factor that we are seeing there, all those factors are linear, so we are going to add the multiplicity, which is 1, so 1, 2, 3. The degree is 3, and the zeros are 0 and positive 3. That's correct. Right, and the zeros are linear factors of a polynomial. What's the relationship between them? Okay, if the zero of a polynomial is x equal r, then its linear factor will be x minus r. Okay, I think the most difficult part there is going to be the negative sign, right? And when we are putting the 0 in the linear factor, remember that there is a subtraction there, so if the 0 is negative, then the linear factor will be x plus, right? Careful there with the signs. And when we are working with rational function, you need to remember that with rational function, in the denominator, we will have a polynomial. And the restriction of a rational function is that the polynomial cannot be 0, okay? And that's going to be an important property that we are going to be using. All right, Justin, good morning. So yeah, I'm going to end the poll here, and we are going to move to our class. Any question before we before we start the class? All right. So close this. Great. Before we go through unit number 8, just want to make I want to remind you that today's registration start today. So if you need help with that, or if you have questions about that, you can reach out to me, and I will put in contact with the correct persons. All right. All right. So let's review one more time, because here I'm going to put what is going to be important from the past units that we are going to be using in unit number 8. We need to remember from polynomial functions, you need to remember that we have the standard form of the polynomial, okay? And we have an equivalent form, which is the factor form. All right? The advantage of the factor form is that now that when we see the polynomial in its linear factors, okay, or at least in its factor, it's easier for us to identify those zeros, okay? So we want to use always the factor form to identify the zeros. If we have the standard form, we need to go to the process to identify the zeros, and then after the zeros, we can identify, or we can put together the factor form. Okay, that is what we did on unit number 6. So yeah, if you have the standard form and your goal is to find the zeros, remember that putting the polynomial in the factor form will help you to identify the zeros. So the example that we just saw, f of x equal x 7x times x minus 3. In this case, this time, I'm putting the exponent too, because now I can put the exponent there. So here we are seeing all the factors of this polynomial, 7 being the leading coefficient of this polynomial. The degree is 3. Okay, and I just want to point out that we have 1 0, that is x equals 0. That is why we have the factor just x, and we have another 0, which is x equals positive 3, that it comes from the factor x minus 3. Another thing that we are going to be using and that we need to remember is the multiplicity of these zeros. The multiplicity of x equals 0 is, what is the multiplicity of x equals 0? And what is the multiplicity of x equals 3? Madeline? That's correct. It's 1. Perfect. And 3? Multiplicity of 3 is 2. All right? We need to remember that the zeros of a polynomial are the x-intercepts of this graph, right? And the multiplicity, okay, so these are the exponent, but we have two categories for multiplicity. We have odd, and odd is, I think, yeah, odd. 2D, I think so, yeah. Multiplicity is odd or even. And what is the behavior of the x-intercepts? What is the behavior of the x-intercept when x is equal to 0 from the first 0? We have two behaviors for odd and even. Do you remember? Cross and touch. So Amanda, like you said, cross is the first one because we have an odd multiplicity, and then we have touch. Okay, touch sometimes I refer as bounds. Okay. Rachel, cross at odd. At even, we have a touch behavior or bounds behavior. Okay. For the rational functions, we want to remember that there is a restriction on the domain, on its domain, and the restriction that the denominator cannot be equal to 0. Okay, and you will remember that from this restriction we got or vertical asymptotes or a hole in the graph. Okay, so keep this in mind, because now what I'm going to do, I'm going to show you how to solve the exercise from unit 8 using the information that is here. Okay, how we are going to take advantage of this information. Right? Any questions so far? From the worksheet of the day, item 12 is the one that gives you all the complete step to solve any inequality when we are working with a polynomial and an inequality. Item 12 gives you all the steps. these are all the steps that we are going to do, but you are going to see how I'm going to use, in this case, for step D, or let me see, 1, 2, 3, 4, step number 4 here, you will see how I'm going to take advantage of the multiplicity of the zero to shorten this evaluation here, okay? Item 13 is where you are going to apply all those steps, but now for a rational function, okay? But let's start with our first exercise of today. All right. So let me put this here, the polynomial and the inequality. All right. All right, like I always do, I'm going to write more here, more than you will need to write on your written work, because I'm going to give you explanation, okay? So this is the exercise that we need to solve. And how we solve this? We need to answer this inequality. What this inequality is saying, or is asking for, or this exercise is asking for, is what are the x values that makes this entire polynomial, okay, let's call it p of x, this entire polynomial, less than 0. So what's the meaning of this? Less than 0 is negative. Okay, and negative what? The y value is going to be negative. Okay, so one of the main difference between an inequality and an equation, so an equation is when we use the equal sign, right? When we are looking for those x values that makes the entire polynomial equal to 0, okay, I'm going to erase this here, we have a finite amount of solutions. X in this case will be x equal 2, x equal -4, and x -7. Now, the inequality here brings a different type of solution, because we are going to find all those x values that makes this polynomial negative. So we are going to have an infinite set of x values. Hence, the solution is going to be given in an interval notation. Okay, so that is the first thing that you need to know from when we're working with inequality, that our solution is going to be an interval of infinite amount of solutions or values for x. You will see how we reach that type of solution just in a moment. All right. The other thing is that on the left side, we have a polynomial, and we know how to work with polynomial. Right now, this polynomial is in its factor form. Some exercises from unit number 8 are going to give you the polynomial in the factor form. If we have the factor form initially, that is going to be a step that we are going let me go back. If we have initially the factor form of the polynomial in the inequality, then the exercise is going to be easier, because we don't need to transform the standard form to factor form, okay? Some exercises are going to give you the polynomial in its standard form, right? And identify the zeros in its standard form You remember from past unit that sometimes it's going to be complicated. So we want to bring the standard form in a factor form. Okay, if the exercise is giving us the factor form of the polynomial initially, then that's going to be good because we don't need to go to all the steps of putting a polynomial in the standard form. Does that make sense? Right? So what we know here, this polynomial that we have here on the left side of the inequality, what is the degree of that polynomial? We have 3, a degree of 3, that's correct, 3 linear factor. And what are the zeros? Mm-hmm. 2, -4, -7. Okay, so see that we are just working with the polynomial. I'm not working with the inequality yet. All right. So let's just stop here for a moment and let's see what's the meaning. Did I write it right? Yeah, meaning of the zero, but graphically speaking. All right. So let me zoom out just a moment. Okay, this part is not part of the written word. This is just to give you an insight of what's happening, what's the meaning of the zeros. But this is going to be important because this is what you have in your mind when you're working with this exercise, and you will see how this is going to help you to complete the exercise. Okay, so I have here the coordinate plane here, and I'm just going to plot the zeros of the polynomial. Okay, so what I'm going to do, I'm going to create regions around those zeros. So -7 is the first zero. So I'm going to use -7 as a boundary for the entire domain of this polynomial. And I'm going to repeat this for -4 and as well for 2. Okay. We know that the polynomial at those values there are x indices because those are the zeros of the polynomial. Let's focus on what will be, or what is the behavior of this x intercept when we are talking about the graph. What is the behavior? We are seeing here that each of these factors have an exponent of 1. When there's nothing there, the exponent is 1. Hence, its multiplicity is odd. So the behavior for all of this is that the graph will cross the x-axis, right? Now, what is the effect of the graph crossing the x-axis? There is going to be a change of sign. Let's assume for a moment that the graph from the left side of -7 of the x-intercept. The graph goes from the above the x-axis. Okay, let's suppose that the graph goes from to the left of the -7. The graph is above the x-axis. What is the sign of the y value here? Is it positive or negative? If the graph is above the x-axis, are we talking about positive value or negative values? They are positive. So if the graph is above the x-axis, it means that we have positive values, right? So because the graph crosses the x-axis at -7, in this region here, are we going to have a positive value or a negative value? Or is the graph going to be, in other words, is the graph going to be above the x-axis or below the x-axis? Amanda, is going to be negative. So it means that the graph will go from above the x-axis to below the x-axis. In other words, the y value is going to be from positive to negative. Oops, and this is to be a negative. Okay, here we are assuming that this is the graph, okay, or at least that the graph on this region is going to be positive or negative. Okay, we do not know the exact graph yet. Okay, we are going to do that at the end. I'm just assuming that on the left side of -7 is positive. The important thing here I want you to understand is that the behavior of the x-intercept that crosses the x-axis means that there's going to be a change of sign. So what will be the sign of the next region? Positive or negative? It's going to be positive, and the last one is going to be negative as well, because the behavior of the graph at those x-intercept is crossing. Okay. All right. Okay. So how are we going to use this to solve this exercise? So now let's focus on the exercise. Any questions so far? Any question about this? All right. So our goal is to find all the x values that makes this polynomial negative, less than 0. Since we are working with a polynomial, the first thing that we want to identify are going to be the zeros. And the zeros in this type of exercise, we are going to call it boundaries. All right, so we are working with a polynomial in an inequality, okay, less than 0. So the boundaries here are going to be the zeros. And the boundaries of what? The boundaries where there is going to be a sign change, or possible sign change, or the boundaries where we are going to have no sign, because when the y value is equal to 0, there's no sign, there's no positive, there's no negative. It's like a neutral sign there, right? So that is how the zeros are going to be working here, because we are looking for less than 0, a solution for less than 0. The 0 of this polynomial works as the boundaries between positive and negative behavior of the polynomial, or values of the polynomial. we know those zeros are +2, -4, and -7. All right, so that's the first step. Okay, before going to the boundaries, let me reiterate again that this exercise is giving us the factor form of the polynomial. So we don't need to do extra work here, because this is what we want to solve an inequality. On the left side, the factor form of the polynomial, and on the other side, the value of 0. Okay, if you don't have this, you want to work before going to this step to have the factor form on one side of the polynomial and a 0 on the other side. A factor form of the polynomial on one side of the inequality and a 0 on the other side of the inequality. Okay, since we have that, we don't need to go through all this process. Then, what are you going to do with those numbers? What I'm going to do here, I'm going to do a number line. I'm going to use a number line that will help me to visualize what we just did here. Okay, what I did here, I just went through the meaning of the zeros graphically, knowing that the zeros represent x-intercepts. To the side of the x-intercept, we are going to have either positive or negative value, right? So basically, we are going to do the same, but in a simplified version, because we are going to use a number line. Because what is important here are not going to be the actual value of the polynomial, it's going to be where the polynomial is negative. Okay, so we are going to simplify the meaning of those zeros. We are going to take advantage of those to solve the inequality. So again, there are boundaries, -7, -4, and +2. Those are our boundaries. Okay, the next thing that I'm going to do, I'm going to name each boundary. So I like to use capital letters to identify my regions. We have here 4 regions. 3 boundaries separate the domain of the entire number line into 4 regions. Region A, region B, region C, and region D. Another thing that I'm going to do, I'm going to identify the interval that represents each region, or the interval of, or the section of the all real numbers of each region. What I'm saying is that we know that this number line goes from -infinity to +infinity, right? So region A goes from -infinity to -7, and I'm not going to include -7. B goes from -7 to -4. C goes from -4 to +2, and D goes from 2 to +infinity. Okay, that way I visualizing all my regions and the number that are contained on those regions. Okay, so why am I doing this? Because we are looking for x values that makes the polynomial negative. Once I have identified the zero of that polynomial, I know that to the side of those zeros, I'm going to have either positive or negative value. Okay, now we want to test each region to know where we have negative values for the polynomial, in which region we have negative values. this having a 0, it is guaranteed that there is no change of sign between the zeros. Okay, between -7 and -4, there is no change of sign here. Okay, that's why we have the 0. That's why we use the zeros as boundaries here. All right. So from the worksheet of the day, now we are going to do. So you know from the worksheet of the day that the next step will be testing those regions with different x values. So I'm going to put this here. Okay. So you are going to see now the two versions on how to solve this exercise. We can identify a value for each region that represents each region, and each x value that represents each region, and then testing the polynomial to see if the y value is positive or negative on that particular region. Or we can take advantage of what we know from the polynomial. We know that the behavior of the graph at -7 is going to be cross, and cross. So the graph will cross at this x-intercept. So there is going to be a change of sign. All right. The other thing that you want to, okay, so the other thing that we are going to do now that we know this, okay, so we need to select representative from each region. Those representatives are going to be the x values. My recommendation for the selection of the x values, we are going to select the easiest values to work with. For example, we are going to start with 0. If we don't have the opportunity to select 0, we are going to select +1. If we don't have the opportunity to select +1, -1. If we are not able to select any of those three numbers, then you can select the next one to the 0, or like I prefer, I'm going always to select multiples of 10. Okay, for example, in region A, you can select -8 because that is the next to the left, the next number to -7. But for me, it is more difficult to work with -8. I prefer to work with -10. Okay, because -10, working with multiples of 10 is like working with 1, but we are going to add those zeros, right? So I prefer to select -10, but you can select -8, okay? As long as a value less than -7, as long as a value that is in this interval. Then here I don't have the opportunity to select -10 or a multiple of 10, right? So the other that I'm going to select, we have two options. We have -6 or -5. I prefer to use -5. I prefer to work with 5 rather than 6. From -4 to 2, here we have the opportunity to select 0. We have the opportunity to select -1, +1, but the easiest or the better choice, in my opinion, from those three is to select 0. And here I'm going to select +10. If I do not have the opportunity to select +10, I will go further and select 100. If I cannot select 100, I will select 1000. Okay, but that is what I prefer to do. Okay. All right. So now we have two options to test these regions. We can use the knowledge that we have of the behavior of the x-intercepts at those, or the behavior of the graph at those zeros or x-intercepts, or we can test all the regions. So we can put here -10, we plug in -10 into the polynomial, we check the value, and we check if it's positive or negative, and we mark if it's a solution or not. That's one option. and you are going to see, and you saw that on the exposed video, you have a complete representation of this method. Now, what I'm going to do here is to show you how you can take advantage of what you know so far. I prefer to work with 0 rather than -5, -10, or +10. So it means that the region that I'm going to test first is going to be region C. So x equals 0. Then when I plug in 0 into the polynomial, so let me grab the polynomial here. And I use P instead of F, so P of 0. Okay, so we are going to substitute all the x values, or all the x variable, with 0, right? Okay, this is important because what we need to know is only the sign of the polynomial, not the value, because we are looking for just the negative y values, right? So what is important here is the sign. So see that now instead of using an equal, I'm going to use an arrow, because I'm going to omit all the values. I'm just going to focus on what will be the sign of each factor. We have 3 factors here. We know that the first factor is going to be negative. We know that the second factor is going to be positive. Okay, 0 minus 2 is a negative value, so -2. 0 plus 4 is a positive value. And the same for the last factor. So we have 3 factors, 2 are positive and 1 is negative. What is the end sign of this multiplication? Or what is the sign that we are going to get here? A positive value or a negative value? When we multiply negative, positive, and positive, we are going to get negative value. And that's what is important here. So what I know that here I have region C is negative. All right. So, but we also know that at the graph at those zeros is going to cross the x-axis. So there is going to be a change of sign. So region D is positive, region B is positive, and A is going to be negative because we change from positive to negative, right? So see now how I took advantage of what we know from the polynomial. So instead of going and testing for all of the regions, just testing for the easiest region for me, and then using the behavior of the x-intercepts to determine the sign of each region, or the sign for each region, so representing the value, the y value for each region, right? So now that we have all this visualized in step number 2, okay, I should put here 3 because this is like step number 3. We knew from the exercise that we were looking for the negative x values that makes this polynomial negative. So let me highlight those regions. Okay. So it means that the solution it is. So the solution, we're just going to take those intervals that we have from each region, from -∞ to -7, union, because we have multiple intervals, -4, +2, and that is my solution. Okay, that is how I answered, or how I solved this exercise. Let me put everything here. Okay, so see how something that could be, that seemed very scary at the beginning, we are working with a polynomial, we are inequality, we are looking for a solution, an infinite amount of x values that makes this polynomial negative. At the beginning, it could seem very daunting, and very daunting exercise. You could say, well, this is very difficult, but see how we were able to solve this exercise in an optimal way by the knowledge that we know or we have from the past unit. Okay, so here is where you want, instead number 2 is where you want to use the properties of the polynomials. Okay, more specifically, the behavior on the x-intercept. Using the behavior of the x-intercept, you can determine the rest. Once you got one region, the sign of one region, you can determine the rest of the rest sign of all the regions, right? So on step number 2, you have two options, or you can use cross, or you can use the behavior of the x-intercept, or you can go and test for each region. Either one is going to be okay. All right. So for written work, no, this is just explanation, so this is not part of the written work. For written work, you want to have these 4 steps here. Okay, this is something, this is the written work for this exercise. Now, on step number 3, if you are going to use the behavior of the x-intercepts as part of your evaluation, at least just need to write something that you are informing me that based on the behavior of the x-intercepts, you are determining the sign of each region. Okay, so for example here, I just put cross, cross, cross. Okay, and that led me to understand that I know what will be the sign of the next region based on the previous one, right? So if you want to just evaluate one region and then determine the other sign of all the regions based on the x-intercept behavior, you need to write something that identify the behavior of those zeros. Okay, what I just did is going to be good enough. Cross, cross, cross. That if I see this, then you will earn all the credit. If you don't identify the behavior of the x-intercepts, then you need to go through all the evaluation through all the regions. Okay, as you did on, or as you will do on the worksheet of the day. All right. So for each region, you test. Okay. So yeah, this is a work for that exercise. Any questions? The other thing that you want to do is, if you have time, you have the graphing calculator, and you can use your graphing calculator to help you to confirm that your results are correct. Okay, so let's see if I am correct. Maybe I'm not. So we have the graphing calculator. Let's just put our polynomial here and let's see its graph. And then x plus 7. All right. So that's the graph of the polynomial. And let's see if the zeros are correct. So we have an x-intercept at -7,0. So -7 is a 0, -4 correct, and +2 is correct as well. The graph to the left side of -7, I don't know how well can you see this, so let me just copy and paste this into the notebook. Okay. Okay, so that's the portion of the graph that it is important to work with this exercise. So there are the zeros. Okay, and we are seeing the graph when is the x value is less than -7, the graph is below the x-axis here. So that means that a negative y value. Okay, so this region is negative. From -7 to -4, we are seeing the graph that is above the x-axis, so we have a positive value for the function, for the polynomial function. Then we have -4, and between -4 and +2, the graph is below the x-axis, hence a negative value for the function, and to the right side is positive. Okay, so see that without seeing the graph initially, we were able to identify the sign of the polynomial function values, okay, for each region. So yeah, this is correct. We were looking for negative values, so from -2 to +2, from -4 to +2 is one region that is negative, and the other one from -infinity to -7 is the other region that is negative. Okay. Any question? All right. Okay, I took too much time on that one. Now let me show you how you will do it on your assessments. Okay. All right, so there is the exercise. Again, we are looking for x value that makes this polynomial negative. Okay. So let's start with identifying the boundaries. The boundaries here are only just the zeros of this polynomial. What are the zeros of this polynomial? We have 3 linear factors. That means that we are going to have 3 zeros, okay? 3 real zeros, or 3 different real zeros, but the degree is 4. And let's see why we have 3 different real zeros and a degree of 4. And what would be the effect of that on our solution? So -2, -8, and +6. Okay, step number 2, let's go to the number line. All right, and let's put those numbers here. What we know, those are the x-intercepts. So they are the boundaries between negative and positive value of the function. I'm going to identify the regions. So that is going to help me to identify, to write the solution at the end. So from -infinity to -8, region B from -8 to -2, region C from -2 to +6, and D from 6 to +infinity. So I'm going to take advantage of the multiplicity of the zeros, but I want you to tell me what is the behavior of the graph at those x-intercepts. So we have 3 x-intercepts. We have -8.0, we have -2.0, we have 6.0. What is the behavior of the graph? So we have a -8 across crossing behavior. Okay, that's correct, because it's the multiplicity of that factor of that 0 is 1, so it's odd cross. -2 stars. because the exponent here, the multiplicity is even, and for 6 we have a crossing behavior. Now, what are going to be the values that are going to select? Okay, so from negative infinity to negative 8, the value that I want to, I will use to represent that region is going to be negative 10. From negative 8 to negative 2, I'm going to select 5. You can select negative 7 or negative 3, negative 4 or negative 6. For me, the easiest value to work with in that interval is negative 5. From negative 2 to 6 is 0, and then from 6 to positive infinity is going to be 10. Right? So I'm going just to test for region C, so x equals 0, then the polynomial here, and again I'm going to substitute the x variable with 0. And what's important here is going to be the sign. What will be the sign? Positive or negative? Okay, we have 3 factors. One of them have an exponent of 2. Okay, so that first one is going to be positive. Then a multiplication of a positive, so positive, and then we have a negative. So the sign is going to be negative. All right. So we have negative sign here. Region D. What will be the sign of region D if the graph crosses at 6? It's going to be positive. Region B if the graph touches at negative 2. Region B, the graph goes from negative, it touches the x-axis. Is there going to be a change of sign when the graph touches the x-axis? There is not going to be a change, so it is negative. Okay. We are going to see this just in a moment in the graph. All right, so region A, sign of region A is going to be positive. All right, so now the number 4 is going to be the solution. And see how quick we did this. The first one I just was explaining everything, but this is what you want to do on the test because you have a time limit. All right, so we were looking for less than 0, so that means all the negatives. Help me with writing the solution. So we know that region B and C are the region where we are going to have negative values. But how are we going to write down that the solution in interval notation? How would you write down the solution in interval notation, knowing that -2 is there in between those regions. Okay, I have ratio with from -8 to +6. Anyone else? What the rest of you think of the solution that proposed Rachel? Amanda, I have from -infinity to -2, union -2 to +infinity. Rachel. That's correct, Rachel. So careful with the inequality sign. Okay, we are not including 0, and we are going to use this one to see all the possible type of inequality here. Okay, but for the one that we have right now, we are not including 0, so we are just focusing on the negative value. So it's going to be from -8 to -2, union from -2 to 6. Okay, so we do not include -2. Okay, any question? All right. So let me put this. Let me erase this. This is not the right one. Okay, what will be the solution for if the inequality is this good there? Maybe not. Maybe let me copy this. Let me move this below. Okay, solution for, let me use some color. When it's less than or equal to 0, so then the solution will include the zeros as well. We know that at -8, and -2, and at 6, +6, the y value is 0. So this is how the solution would look like. From -8 to 6, okay, that's correct. But what would be what would use to close the boundaries here? Parentheses or square bracket? Square bracket, because we need to include -8 and -6. All right. So the solution for greater than 0. If we are looking for greater than 0, how would you write the solution? When you see this well, let me copy and paste this below. Okay, if the exercise is looking for the values of x that makes this polynomial greater than 0, it would be from -infinity to -a union to infinity, correct? -infinity to -8 union to from -6 to positive infinity. And the last one will be when we include greater than or equal to 0. How would you write this, the solution? What would change? The square brackets. From negative infinity to -8, square bracket union, -6 to positive infinity. All right. So those are the different versions that you can have on an inequality exercise. Okay, careful with that. And the most important part before getting to the solution is finding the boundaries, putting the number line there, and then doing the evaluation. The evaluation, if you know the x-intercept behavior, then you can take advantage of that. If not, you need to test for each region. Again, the written work, it will be these 4 steps. See how I solve this exercise very quickly in the minimum amount of steps. This is what you want to do on the quiz and the test. Okay. Remember that if you are going to be using the x-intercept behavior, put something on the paper that identify or tells me that you are using the behavior of the x-intercept. Okay. If not, you need to do the evaluation for each of the regions. All right, so we have been here 1 hour. We still have a few more exercises. Okay, the other one is to solve the inequality for 2 rational functions. But let's take a break. Let's take a 5 to 10 minute break. Any question before we go to a break? All right, so we are going to get back here around 9:15. I think that's a good time to break. Okay, Madeline. Yeah, you can watch the rest of the class later. Okay. Thank you. Okay, so I'm going to get back here in around 5 to 10 minutes. Okay, let's take a break.